All right, so let's get going. For these two questions, there are a few ways you could have done it. I saw some people graphing. That is absolutely one way. So if you graphed all three of those points and then saw if you could draw a line through them if they were a linear function, that is absolutely one way. You're going to find out that both of them are linear, okay? I'm going to show you how to do it just using the slopes, okay? So what we're going to do is we're going to define, since they're points, we're going to define one of them as x1, y1, and one of them as x2, y2. So for our first example for A, we're going to define A as x1, y1, and then B is going to be x2, y2, okay? And what we're going to do is we're going to use the slope formula to find out what the slope is between those 2 points, okay? So our slope formula, if you remember, is rise over run, but in this case when we have points, it's going to be the difference in the y coordinates divided by the difference in the x coordinates. So it's going to be y2 minus y1 over x2 minus x1. Guys, what's my y2 in this example? Tessa? 2. And then we're going to take away y1, which is? 3. We're going to divide by x2, which is? 4. Minus, and then x1? 1. 2 minus 3 is going to give us negative 1. And 4 minus 1 will give us 3. So our slope is negative 1/3. Now that's the slope between A and B, okay? Now to find out if C also lies on that line, we have to find the slope between C and either A or B. I'm going to use A, and I'm just going to label C as x2, y2. So I'm going to change my x2, y2. As long as the slope is still negative 1/3, we can tell that C also lies on the same line. So we're going to use that same formula, y2 minus y1 over x2 minus x1. So in this case, we've got 4 is our y2 minus 3 over x2 is now negative 2 minus 1. 4 minus 3 is going to give us positive 1 in the numerator. And in the denominator, we have negative 2 minus 1, which will give us negative 3. Are these slopes the same? Yes. Since the slopes are the same, we can say that A, B, and C all lie on the same line. If you graphed them, you would also see that your slope would be negative 1/3 and your line would go through all 3 of those points. Who graphed it? Okay. $51. G, H, and I. So let's do the same thing, okay? So G, we're going to make x1, y1. H, we're going to make x2, y2. So now our formula is y2 minus y1 over x2 minus x1. In this case, y2 is 3, y1 is 5, x2 is negative 1, x1 is 3. So now we've got 2 minus 5 is negative 2 over negative 1 minus 3 is negative 4. Negative 2 over negative 4, what does that simplify to, guys? What is it?
Is it 1/2?
Mm-hmm. How'd you get that?
Divide 2.
Yep. Yeah, you can divide by 2 to both the top and the bottom. Very nice. All right, guys, lastly, let's change our x2 and y2 to make it I. So let's make x2I and y2I. So we've got 7 and 7. And let's now write a new formula. So we've got y2 minus y1 over x2 minus x1. Our x1 and y1 is going to stay the same, which is just g, but now our x2 and y2 are going to be I. So we've got 7 minus 5 over 7 minus 3. 7 minus 5 is 2 over 7 minus 3 is 4. 2 over 4 is the same as 1/2. Oops. Are these slopes the same? Yep. Therefore, G, H, and I lie on the same line as well. Questions on the warm-up, guys? I know we did not know how to do this, okay, going into this lesson, but I wanted to see what you guys would try. So I know a lot of you tried to graph it. That is absolutely fine, okay? If you graph it, as long as you see that there's a line that goes through all three, ayo, we're good to go, okay? I just wanted to see how you tried to solve this problem on your own. All right, guys, so this lesson is 5.2, direct variation, okay? And go ahead and put your name, and we're going to get started. Our objective in this lesson is to write and graph an equation of direct variation. So underneath that, once you copy that down, I want you to write y equals mx plus b. Okay, so y equals mx plus b is normally how we see a linear equation, right? It's normally what we use as our template. Imagine b is 0. What would my equation be? If b is 0, what would my equation now be?
Here, bro, can I solve it?
Go ahead.
Isn't it y equals mx plus 0?
Plus 0. Do we need to include the plus 0?
Or, yeah, no, nothing.
Yeah, we don't need to include that. So if we take that out, y equals mx. This, guys, if you box it in, is an example of direct variation, okay? Direct variation is wherever you have y and x, and the only thing that relates them is a constant m. Now, when we call it direct variation, we're going to use a different letter. It's going to be k, but it's going to represent the same thing. It's going to represent the slope, okay? Y equals mx. So we can basically forget about B in this lesson. All right, moving on. Direct variation. So if the ratio of two variables is a constant, then the variables have a special relationship, which we just talked about, is direct variation, okay? A direct variation is a relationship that can be represented by a function in the form y equals kx. So you see how k is now our m, where k is not equal to 0. The constant of variation for a direct variation, k, is the coefficient of x. So whatever's being multiplied by x when you solve for y, that will be your coefficient of variation. By dividing each side by y equals kx by x, you can see that the ratio of the variables is constant. So y over x is going to be equal to k. To determine whether an equation represents a direct variation, solve it for y. If you can write the equation in the form y equals kx, where k is not equal to 0, it represents a direct variation, okay? So what we're going to be doing is we're going to be determining whether something is a direct variation, and then we're going to find out what the k is, okay? Who needs more time on this slide? Raise your hand. Okay, about 1 more minute, guys. All right, guys. Identifying a direct variation. So in each of these equations, we're going to find out whether it represents a direct variation. And if it does, we're going to find the constant of variation, which in our case, okay, underline that and put that is going to be our k, okay? Your constant of variation is your k. So whatever's being multiplied by x. So for each of these problems, you're going to solve for y. So we want to get y by itself on that left side of the equation. So we've got 7y equals 2x. Guys, how do we solve for y in this equation, in A? What do we have to do?
Divide by 7.
Good, Roy. We just divide both sides by 7. This left side, this 7 is going to cancel. We're going to get y equals 2x over 7. Now, one thing that's nice is we can take the x outside of the numerator and put it on the side because we're multiplying. So we can write it as 2 over 7 times x. If we compare this to what our direct variation equation is, y equals kx, are these in the same form? Do we have y equals a number times x? Yes, we do. Okay? Our number in this case, or our k, is 2 over 7. It's whatever number is being multiplied by x. So in this case, it's that 2 over 7. Okay? B, 3y plus 4x equals 8. Guys, what do I have to do to solve for y? Tessa?
Wouldn't you like subtract?
Subtract first. Very good. Don't divide by 3 first, guys. We still have another term over there. What do we want to subtract by, though? What do we want to get rid of on the left side?
The 3, 1, the 3, or is the 4?
the 4x, okay? We want to deal with what's next to the y second, right? Because that's going to be division or multiplication. So what we're going to do is we're going to subtract 4x from both sides. So on this left side, guys, we're going to get 3y equals negative 4x plus 8. Or 8 minus 4x. I'm going to rewrite it with the x term first, though, okay? Negative 4x plus 8. Now we divide by 3 to both sides. And what we're going to get is y equals negative 4 over 3x plus 8 over 3. We just distribute the 3 to both terms. Guys, is this in the form y equals kx? Someone said no. Why? Oh, you said yes? Take a look at the 8/3. Okay, that's what's messing us up for writing this as y equals kx. Because remember, 8 over 3 would be our b, right? And for direct variation, b has to be equal to 0. So because this 8/3 is there, guys, this is not direct variation. Not direct variation. So when you should always have y equals a number times x. If you have anything other than that, anything other than kx, it's not direct variation. Now, let's say the 8/3 was not there. What would my k be? Anderson? Negative 4 over 3. At A, notice how we didn't have a constant at all. Every single number had a y or an x attached to it. And then in B, we had that 8. If you have a number that has nothing next to it, so no x and y, so it's a constant, it's not a coefficient, you are not going to have a direct variation, okay? Let's take a look. Going. We're going to do another example. Identify a direct variation. So does 4x plus 5y equals 0 represent a direct variation? If so, find the constant of variation. Guys, always, 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 first thing we do is we solve for y. How do we solve this for y? Alan? Good. Subtract 4x from both sides. That's perfect. We got 5y equals negative 4x. Because remember, 0 we can just kind of ignore. Because it's going to be 0 minus 4x, which is just negative 4x. What do we do next? Tessa?
Wouldn't you divide 5 on both sides?
Mm-hmm. So we've got y equals negative 4 over 5 times x. Is this direct variation? Anderson?
Yes.
Why?
Because there's no number after that.
Yes.
If there was a 0 and just a 0 on the right side of the equal sign, couldn't we say just then and there it is a direct variation?
But in order to find out what your k is, you do have to solve for y, okay? So k is what in this case?
Negative 4 over 5.
Negative 4 over 5. Okay, guys, so when we are solving these kinds of problems, okay, from the very beginning, if you have a 0 or no constant at all, right? So take a look back at, see how this was 0 on the right side? We knew that this was going to be a direct variation because there's going to be no constant. Every single value, the 4 and the 5, had an x next to it or had a y next to it, okay? There was no constant. Our constant was 0. Oops. Questions? All right. Writing a direct variation. So now we're going to be given that it is a direct variation and we're going to come up with the formula, okay? So if we know that x and y vary directly, okay, that's what it tells us. Y equals 35 when x equals 5. Write a direct variation equation that relates x and y. And what is the value of y when x equals 9, okay? When we know that it varies directly, our equation is k equals y over x. If something varies directly, we know that our equation is y equals kx. You can divide both sides by x and get k equals y over x. If y is 35 when x is 5, y is 35 when x is 5, my k then becomes 35 divided by 5, which is just 7. So my direct variation equation is y equals 7x. What is the value of y when x equals 9? So y is going to be equal to 7 times 9, which is just 63. Questions? Don't worry, we're going to do another example. Suppose y varies directly with x. Y equals 10, x equals negative 2. What's my equation for k? If we know that they vary directly, k is going to be equal to? Tessa? Y over x. We're going to plug in what it gave us. So it says when y equals 10, x equals negative 2. So let's plug in 10 for y. So we're going to get 10 over x is negative 2, 10 over negative 2. Does this simplify? To what, Anderson?
Negative 5.
Good, negative 5. So k is negative 5. What's my direct variation equation then, in terms of y and x?
K equals negative 5x.
K equals negative 5x?
No, y equals.
Y equals negative 5x. Very good, right? Because what we want to write it as is y equals kx, and we know what k is, so we just put negative 5 for k. How do we find out what y is when x equals negative 15? All you do is plug it in, guys. So when x equals negative 15, y equals negative 5 times negative 15. We get y equals 75. Any questions on writing a direct variation equation? Whenever you see varies directly, you guys should automatically think of these two equations. Y equals kx and k equals y over x. All right. graphing a direct variation equation. So before we get into this one, we take our last problem that we did, we got y equals negative 5x. And we are going to graph that, okay? So let's draw our axes. This will be our y-axis. This will be our x-axis. Y and x. Let's label our increments. Let's go by ones. So 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5. 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5. Our slope is negative 5. Why? Because that's our k. Our slope is negative 5, and we know one of our points is this one right in the middle, 0, 0. Direct variation, always, 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 one of your points is right in the middle. So now using the fact that our slope is negative 5, right? Our slope is rise over run, right? So negative 5 is the same as negative 5 over 1, correct? So our rise is going to be negative 5, and our run is going to be positive 1. So if our rise is negative 5, we're going to go down 5 units. So from 0, 0, we're going to go down 5 units. So 1, 2, 3, 4, 5, down 5 units, and then to the right, 1 unit. This is where we're going to stop, okay? Go ahead and turn in your notes, and you guys are good to go. Have a great day. I'll see you back tomorrow.
This horrible class.
Bye.
Why over?
Have a great rest of your day, everyone.
Bye, Carlos.
Bye, thank you.
Bye, Angelina.
I'll go see your girl.
Bye, Giancarlo. Thank you.
Thank you. Bye, Mr. Yoko.
Bye. Have a good one, guys. Okay, so we know that our slope is negative 5, run 1. Rise negative 5, run 1. So we went down 5 and then to the right 1. We're going to do that again, and then we'll have 3 points and we can just draw a line through them. So let's go down 5 units. 1, 2, 3, 4, 5, right at the edge of our graph. And then over 1 unit. Here's our third point. And we just draw a line connecting all of those. There's our graph. Okay, make sure if you ever have direct variation, that's where all you have is y equals kx. Your graph should always go through the very middle of the graph, which is the origin. Okay, go to the next slide. The graph of a direct variation equation, y equals kx, is aligned with the following properties. The line passes through 0, 0. And the slope of the line is k, all right? So k is our slope, and it must pass through the origin. So we know for direct variation, it's not going to be up here or down here. It's going to pass right through the middle of our graph, okay? And then the k is just going to be our slope. So, all right. Lastly, we're going to write a direct variation from a table. So for the data in the table, does y vary directly with x? If it does, write an equation for the direct variation. So what we have to do is we have to check each of these points in the table and find out if our k is equal in all of them. So for them to vary directly, k must be equal to y over x. That's just our equation. And we're going to plug in for each of these. So in the first one, we've got y equals 6, x equals 4. So k equals 6 over 4, which reduces to 3 over 2. In the second one, we've got k equals 12 is y, and 8 is x, so 12 over 8. 12 over 8, you can divide both the numerator and the denominator by 4. You would get 3 over 2 as well. And for the last one, you've got k equals y is 15, x is 10. 15 over 10. You can divide both by 5, and you get 3 over 2. As long as all of the k's are the same, you have a direct variation. So let's do the same thing for b. Let's take a look at each of those points, and let's figure out what our k is. So for the first one, we've got k equals y over x, which is going to be 3.2 over negative 2. 3.2 over 2, over negative 2 is going to be negative 1.6. Second one, we've got k equals 2.4 over 1, which is 2.4. We can stop here. See how these are different? If they're not the same, okay, all of them have to be the same. This is not a direct variation. Here's your lesson check. These are some questions for you guys to try on your own. Here are the answers, and then an exit ticket and your homework. All right, guys, good luck. Let me know if you have any questions.